Welcome everybody. A subscriber asked me this question, so I'm going to provide the solution here. Foremost, I wish to rewrite this as integral ln of x positive 1 divided by x squared negative, of course dx should be there, negative integral x times dx positive integral dx. Now these two are easy to be integrated. Now I would like to first consider integral ln of x positive 1 over x squared times dx. Now I'm going to use integration by parts, so let u be equal to ln of x positive 1 and dv is equal to 1 over x squared times dx. If you were to integrate this both sides, this is going to be v is equal to, I can rewrite this as x raised to the power of negative 2 times dx. So if you were to apply the integration, this is negative 2 positive 1 divided by negative 2 positive 1, which is equal to x raised to the power of negative 1 divided by negative 1, which is equal to 1 over x with the negative sign, and this is going to be my v. Now differentiating this, you get 1 over, I'm going to write this as 1 positive x, okay, that's a logarithmic differentiation, multiplied with the differentiation of x, it's going to be 1. We need to place the differential operator dx. So the formula is uv negative integral d du, which is equal to, my u is ln of 1 positive x, my v is 1 over x, so I place the x here with the negative sign, negative integral, my v is 1 over x, so it's become positive, my du is going to be dx over 1 positive x, so that's going to be x into 1 positive x. So this is what we have got, right? But we need to integrate this. So this can be rewritten as, you can use integration partial fractions, but what I would do is I would just take x out. If I were to take x out, I would get x into x times 1 over x positive 1, and on this end you are going to be having negative ln of 1 positive x divided by x. So I would like to consider this first. So instead of just subsequently placing in the steps, which would be time consuming, I just consider this. Consider integral dx over x squared of 1 positive 1 over x. Okay, so let me take the substitution. Let 1 positive 1 over x be equal to some p. So if you differentiate 1, you get 0. Differentiate this, differentiation of this is going to give you, actually it is 1 over x, right? So I can write it as x raised to the power of negative 1. I differentiate, I get negative 1 times x raised to the power of negative 1, which is equal to negative x raised to the power of negative 2, which is going to be negative 1 over x squared. Okay, so this is going to give me negative 1 over x squared times the dx is equal to dp, but we don't have a negative sign, so therefore dx over x squared is equal to negative dp. So this is what we've got. To take this and substitute here, so it's going to be, in place of dx over x squared, I have dp with a negative sign, I place it here, and you have 1 over 1 positive x, that's going to be p there. So this is going to be equal to negative ln of p, which is equal to negative ln of 1 positive 1 over x. Okay, so that is what is this value when we integrate this. So now what we need to do is we need to take this and substitute here. So if I were to take this as 2, so therefore 2 is rewritten as negative ln of 1 positive x divided by x and followed by negative ln of 1 positive 1 over x. Now what you need to do is you have to take the value that you have got here. So this is the value that you have got here, and then you have to rewrite this. So if I were to take this as 1, I'm going to use another sheet of paper. So therefore integral ln of 1 positive x divided by x squared times dx is equal to, this is the outcome, right? So take all of this and write it down here. So this is equal to negative ln of 1 positive x divided by x, negative ln of 1 positive 1 over x. Okay, So now what we need to do is we can actually take all of this and substitute it here. So let me write this as 1 dash. So therefore 1 dash is rewritten as, this is equal to negative ln, I'll just place in the modulus sign, 1 positive x divided by x, negative ln of 1 positive 1 over x, negative, you integrate this, you get x squared over 2, you integrate this, you get x. So this is what you've got. Now what you can do is you can take the negative sign out and rewrite this as ln of 1 positive x divided by x, positive ln 1 positive 1 over x, negative x squared over 2 positive x. Now we know that ln a plus ln b is equal to ln of ab. So substitute that, use this formula over here. This is going to be negative ln of 1 positive x times 1 positive 1 over x, negative x squared over 2 positive x. Now taking x to be positive, if we can clearly see there isn't any restriction here because of indefinite integrals, so this can be rewritten as ln of 1 positive x over x times, this can be rewritten as x positive 1 over x, negative x squared over 2 positive x. This is equal to negative ln of, this is 1 positive x, 1 positive x, so it's going to be 1 positive x raised to the power of 2 divided by x squared, negative x squared over 2 positive x. Now I can rewrite this as negative ln of 1 positive x over x. This entire 2 can be placed over here and followed by negative x squared over 2 positive x. Now if you have a times ln b, this is equal to ln of b raised to the power of a, right? Now you take the negative sign over here, so this is going to be ln of 1 positive x over x raised to the power of negative 2 followed by negative x squared over 2 positive x. Now you can actually flip this, right? This is 1 positive x over x raised to the power of negative 2, so this can be rewritten as ln of x squared over 1 positive x whole squared, negative x squared over 2 positive x, positive arbitrary constancy. Okay, so that is the solution for this question. So this is the question, we started with this and then this is the final answer. Thank you everybody, please like, share and subscribe.